Let me see.
Wave, Reese. Wave. Mason. Wave. Kelly. Okay. Good. All right. Can you think of the worst storm that's ever hit you? Where you were, who you were with, what you felt? According to the National Weather Service Fatalities Report in 2015, there were 522 deaths, 2,143 injuries, and $4.8 billion of damage due to weather-related events last year. These were caused by wind, flood, heat, rain, and even dust. This is the power of storms. These kind of storms affect people just like you every day, and wouldn't it be cool to know just how one of them works? I took an atmospheric science class last semester, studying everything from temperature change to how a hurricane gains its power. But today I want to talk about what brought me the most interest and what is completely relevant to you: the formation and the effect of cold and warm fronts. Cold and warm fronts, although both low pressure systems, are formed differently and produce much different results. Let's first look at the formation of cold fronts. According to Donald Ahrens in his 2016 lecture called Air Masses and Fronts, cold fronts come from the northwest and move towards the southeast. As you can see from this image taken from the University of Illinois Atmospheric Science Research Center in 2010, a cold front moves underneath a warm front, pushing the moisture up into cumulonimbus clouds. This builds up a cloud until the water droplets reach the top, which starts the cold rain process. In the cold rain process, water particles are turned into ice, and when they reach heavy enough, they drop into the middle of the cloud, where they combine with supercooled water until they're big enough to fall out of the cloud and melt to become rain. The College of DuPage 2016 article says, in cloud physics, the Bergin process describes the process as ice freezing and the Bergin process. Once the front passes, it's easy to identify because it brings cold, dry air. Another way to recognize a cold front is on a Stuve diagram. With this diagram taken from Anna Huber's website, Plymouth State Weather Center, 2004, we can see a temperature line and a dew point line. When the temperature line and the dew point line are together, that means there's clouds. If it's to the right, that means it's stable, and if it's going to the left, it means it's unstable. Here we see it starts out as a stable cloud, which is warm, and then turns left and becomes unstable clouds, which is the formation of a cumulonimbus cloud, which is also a cold front. Now that you've heard about cold fronts, let's see the difference in warm fronts. During the foundation of a warm front, NC State University's 2013 article named Fronts says that these fronts come from southwest winds from the Gulf and from the hot south and move up to the north where the wind is colder. This creates low visibility and begins the warm rain process. In the warm rain process, warm air moves over a cold body of air to create a big sheet of stratus clouds. In the hot afternoon, the air particles can be forced up to create thunderstorms in cumulonimbus clouds. According to the 2008 University Corporation for Atmospheric Research article, Intro to Tropical Meteorology, stratus clouds are common, but in the afternoon it can bring big thunderstorms. In this process, the rain is pushed up into the top of the clouds where it collides with other rain droplets until they get heavy enough to drop out the bottom. Once this passes, there's an increase in temperature and an increase in humidity. As you can see, warm and cold fronts are both similar in the fact that they bring rain, but very different in the way they bring it. Hopefully now you can tell what kind of front is going to hit you, and maybe what to expect when it does. I would encourage each of you to take an atmospheric science class, because who knows, it may be your calling to be a weatherman, but if it's not, maybe it could save your life. Clap for me, clap for me, clap for me.
I thought they gathered.
Father, mother,
I thought there's nobody there.
I know it blacked out.
What?